Today we're going to be focusing on average atomic mass. Not average atomic structure, average atomic mass. Okay, what is the average atomic mass? The average atomic mass is the mass of all of the atoms of a particular element, and it's a weighted average, okay? Because there are these different isotopes of, let's say, oxygen. So oxygen can have a mass of 16, oxygen can have a mass of 17, and oxygen can have a mass of 18. And if I put all of them into a bag, most of them will be one type versus another. They're not all going to be 33.3% of the time being 16, and then another 33.3% being a 17, and another 33.3% being an 18. The majority of them actually are going to be oxygen 16. Okay, and so what a weighted average does is it takes into account the actual percentages that they're contributing. It's the exact same way that we calculate your semester grades, as we take 80% of your semester work and then 20% of your final, and we average it all together. It's not like we take just the semester plus your final grade and divide by 2. We take more weight into and more percentages from the semester grades as opposed to the final. So isotopes, here's an example problem. Nitrogen is made up of 2 isotopes, nitrogen 14, and remember that means that this isotope has a mass of 14, and nitrogen 15, which has a mass of 15. Given the nitrogen's average atomic weight is 14.007, which isotope is most common? So you have 2 options, okay? You have nitrogen 14 and you have nitrogen 15. Well, when you're trying to figure out which one's the most common, you look at your average. What is it closest to? Well, it's a lot closer to nitrogen 14 than to nitrogen 15 as far as an average goes. I mean, that's pretty close to 14. So nitrogen 14 is found the vast majority of time compared to nitrogen 15. Only if the average was a 14.5 would we know that they are equal in percentages, okay? Because if I did 14 plus 15, I divide by 2, I would get 14.5, but that is not the situation. We get a number much closer to 14, so therefore nitrogen 14 is the most common. This is the formula when we ask you to calculate the average atomic mass of an element or of a substance you're going to use. It's very easy, it just looks wordy. So you're going to take the mass of your isotope, times it by its percent abundance, plus a mass of the other isotope plus its percent times its percent abundance, plus, and you keep going on because some of these guys will have more than 2 isotopes. And you just keep doing it, multiply it to its percent, and then you press equals, and then you divide by 100, and that is your average mass. So let's try to do an example problem. The element gallium has 2 stable isotopes, gallium-69 and gallium-71. Gallium-69 has a molar mass of 68.9 grams per mole, so you're going to use that for its mass, not that 69. If I didn't give you this number, then you would use the 69 as its mass. So we're going to use this as its mass. And gallium-71 has a molar mass of 70.9 grams per mole. Gallium-69 has a relative abundance of 60.1%, and gallium-71 has a relative abundance of 39.89%. So what that means is that 40% of the time, rounded, I would choose gallium-71 and if I had a bag of gallium. Okay. What is the average atomic mass of gallium? So what we're going to do is we're going to take the percentages, and I underline the ones that go together. You want to make sure on these problems that you match up the correct mass with its correct percentage. So what we're going to do is we're going to take 68.9 mass times its percent, which is 60.11, plus the mass of the other isotope times its percent. And if there was another isotope, you would keep going. So you do plus and then you'd combine those, okay? And then you divide all of that divided by 100. So make sure you just do the multiplication and the addition on top first. Press enter and then do the division by 100. Otherwise, because of the order of operations, it won't do it how you want it to. So just do it in little sections. So do the top number, which I get, when I multiply it, I get 6969.78 divided by 100. And I'll get an average of 69.70, and then that would be grams per mole. I'm just copying the unit. It's not as big of a deal for this because we haven't even talked about moles yet. Now, when you're doing one of these problems, what I do want you to take note of is that a lot of times people will forget to divide by 1,000 or 100, and they're going to get this huge number, and then that's what they write down as the average. So logically think through this, okay? So if either your mass is 68.9 or 70.9, would your average mass be 6,969? You should say no, so something went wrong. Okay, so make sure that you're logically thinking through this. In addition, I have 40% of the time it's about 71, and I've got 60% of the time it's about 69. So my average is a little bit closer to 69 than it is to 71. So this makes sense to be my average atomic mass. Okay, so just think through these problems, make sure that they make sense and your final answer, because it's probably just a simple error if you do anything wrong. But really, it's pretty simple. Mass percent plus mass percent divided by 100. Have a great one.